Hello everyone. Today we are going to be looking at the graph of tangent functions. We all know what a sine x and a cosine x graph look like, but what does a tangent graph look like? We all know tangent x is defined as sine x over cosine x. If we look at this definition of tangent x, this is a fraction. Now, there is one condition for a fraction to exist. For a fraction to exist, its denominator cannot be 0. But why? Because any number over 0 will give you a math error. You can try this in your calculator. Now, what are the values of x that make cosine x equal to 0? They are 90 degrees, 270 degrees, 450 degrees, and so on and so forth, where to get the new numbers, you just add by 180. How do I know this? When you look at the graph of cosine x, when x is 90 degrees and 270 degrees, they will give a y value of 0. And if you were to repeat drawing the cosine curve, the other values of x that will make cosine x 0 is just calculated by adding 180 to 70, which will give you 450. And the next number will be 450 plus 180, and so on and so forth. So these are the values of x that make cosine x 0. So in summary, okay, tangent x is defined by sine x over cosine x. For tangent x to have values, the denominator, which is cosine x, cannot be 0. And the values of x that make cosine x equal to 0 are 90, 270, and so on and so forth. But let us just focus on these two values first. Now, tangent x cannot have a value when cosine x equals to 0. And as we know, cosine x is 0 for these two examples of x, 90 and 270. So, over here, I wish to draw y equals to tangent x. And for x equals to 90 and 270, tangent x or the y cannot have a value. So how do I draw a graph such that when x is 90 and 270, there is no y value? Can this be a possible tangent graph? The answer is no. Simply because when x is 90, there is a y value. And when x is 270, there is also a y value. But we wanted the graph to not have a y value for these two values of x. So how do we actually draw such a graph? Now, one such graph will be like this. As you can see, when x is 90, the graph does not have any y value. Or the graph is to the left and to the right. The graph never crosses this red line. Over here, when x is 270, there is no y value. The graph is here and here. The graph never crosses the red line. So this is a good example of a graph that cannot have a y value when x is 90 and 270. Now, this red line that I drew here is special. They are special. They are to indicate that the graph cannot cross these lines. So these lines are like a border. You cannot pass through it. Now, this special line is called an asymptote. An asymptote is a line. It can be horizontal, it can be vertical, or it can be at any angle. It is a line where the graph cannot cross it. And for our tangent x graph, these are the two special asymptotes. Our tangent graph looks like this. And as you can see, the graph never crosses the asymptote. Okay? And this graph will continue forever. The next asymptote will be at 450, and the next one will be at 450 plus 180, and so on and so forth. So this is tangent x drawn from 0 till 360. And only for tangent x, there exist asymptotes, values of x where y has no value. And if you were to take a closer look, you will notice that the graph here is almost reaching the line, almost reaching but never touch. Same goes here. The graph is almost touching the line but never touch. Same goes here, and same goes here. So this is the proper way of drawing a tangent x. Near the asymptote, the graph is almost touching but never touch. It cannot touch. Okay, that is a definition of an asymptote. And if I were to extend the drawing of tangent x, it will look like this, from negative 450 to 450. Now, let me ask the following. Is there an amplitude to tangent x? The answer is no. Recall, amplitude is the distance from the highest point to the axis of curve. The axis of curve for tangent x, it is the x-axis. However, there is no highest point. The graph will go on forever and forever. There is no lowest point. The graph will go on forever and forever. Thus, there is no amplitude for tangent x. However, there is period. Recall, what is period? Period is the value of x where the curve repeats itself. Okay? If we do not look at the negative values of x, if we were to look at this side, so let me block it. Now, can you tell me what is the period of tangent x? What is the value of x where tangent x repeats itself? The answer is 180 degrees. If you look closely, like that, one complete wave. One complete curve. Then it continues here and here. And then it will continue here and over here. So for tangent x, the period is 180 degrees. And recall, sine x and cosine x, their periods are 360 degrees. So note the difference. Now, if I were to ask you to draw this tangent x where there are the transformations of A, B and C, how will it look like? Now, the laws of transformation are the same as when they were for sine x and cosine x. So you will do the effect of A first. What does A do? It will stretch the tangent curve vertically. What does B do? It will compress the tangent x horizontally. And what does C do? It will bring the tangent x up. So it is the same transformations as sine x and cosine x. So let us end off with the essential points of a tangent graph. Okay? By definition, tangent x is sine over cosine, and because a fraction cannot exist when the denominator is 0, therefore y equals to tangent x cannot have any y values at these specific values of x. These values of x are what make cosine x 0, which are not allowed for a fraction. And thus, we have this graph where the forbidden values of x, okay, are what is known as asymptote. Asymptotes, again, are lines where the graph cannot cross. And this is a graph of tangent x drawn from 0 degrees until 360 degrees. There is no amplitude and the period is 180 degrees. That's all.